This video is to help you go through your classwork for 3.1. Make sure you have your lab sheet as you're working through it. So what are we going to be learning about in Investigation 3? Well, we're going to be learning about the Pythagorean theorem. So this is kind of a big moment as we start putting some of these big pieces together. Previously, you've learned about properties of triangles, and we're going to learn about a special property in problem 3.1. You know, hopefully, that all triangles have 3 sides and 3 angles. You can probably see some differences between these 3 triangles below. Hopefully you remember some of that vocabulary related to triangles. And in particular, make sure you note that triangle A is an acute triangle. Remember that an acute triangle has 3 acute angles. Triangle B is an obtuse triangle. An obtuse triangle has 1 obtuse angle. And triangle C is a right triangle. And a right triangle has 1 angle with a measure of exactly 90 degrees. We call that 90-degree angle a right angle, and it's often marked with a small square. The longest side of a right triangle is the side opposite the small square, so we're talking about this side right here, and we call that side the hypotenuse. The other 2 sides are called legs. So make sure you know some of these vocabulary pieces because they're going to be coming up more. There's also a question here that says, can a triangle have more than 1 angle that is 90 degrees? Well, you might not have remembered there's a specific sum of the angles in a triangle, and the sum of angles in a triangle needs to be 180 degrees. So if you think about the fact that a triangle has to have a sum of 180 degrees, and it has to have 3 angles, it is not possible for me to have 2 90-degree angles plus another value to make 180 degrees. 90 plus 90 would automatically get me to 180. But a triangle has to have 3 angles. So make sure you understand that it's not possible for a triangle to have more than 1 90-degree angle. So in this investigation, you're going to use squares, which we've been working with for a while here, to find the side lengths of acute, right, and obtuse triangles shown below. So you have this on your lab sheet if you want to pause for a minute and find the areas yourself, and then you can check back to see what your areas should be. So looking at the first triangle here, this is triangle 1 on your lab sheet, we can find the area of, for example, side A. This is 3 by 3, so this is an area of 9. And that specific side length here is the side length of the square root of 9, which would be 3. Looking at side B, I see that I have a 4 by 4 grid, so that has an area of 16. And that side length here is going to be the square root of 16, which is exactly 4. In the case of C, I have to do a little bit more work to figure out the area. And one way to do this would be to kind of create some right triangles and some squares inside. So I have an area of 1 in the middle, and then each of these triangles is 3 by 4, but half of that, so 3 times 4 is 12, divided by 2 is 6. So each of these triangles is worth 6. So 6 times 4 gets me to 24, plus 1 would be 25. So this has an area of 25, and that means that this side length here would have a value of the square root of 25, which would be 5. So again, you're going to continue working through each of these. Make sure that you can find the area of each square, then the area, or the length of each side length, and you're going to put that information into your table. This is a copy of the questions from the book. Again, make sure you have your table completed on the lab sheet, and then also take a little bit of time to draw a right triangle, an acute triangle, and an obtuse triangle on your lab sheet, and you're going to fill in the other sections of your lab sheet then. You're also going to work on problem B, where you're going to think about what is the relationship among the areas of the 3 squares on the sides, and think about what's happening in the situation. When you're ready to correct your answers, go on to the next part. If you're not ready yet, go ahead and pause the video. The first part of answers here is just the answers to the table, so what you should have for the areas of each square as well as the lengths of each side. Note that 2, 4, and 6, it's up to you to create, so all those answers will vary depending on what you found. Question B asks us to look for a relationship, and what we're hoping you're noticing is that in a right triangle, the area of the square on the hypotenuse is equal to the sum of the areas of the squares on the legs. So just to kind of make it clear what we're saying here, this is my right triangle. The area of this square on the hypotenuse, which again is the longest side, which is opposite the right angle, this area of the hypotenuse is equal to the sum of the areas of the squares on the legs. So this area plus this area combined together will give me the area of the hypotenuse. And so again, we're going to describe that a little bit more in future lessons, but for right now, having this idea recorded in your notes will be very helpful. We're also going to make it into equation a little bit later. Again, if you don't know that equation yet, don't worry, that's coming. The other question here asked about making a conjecture. And so again, this is an example of a conjecture that someone made. Yours might be a little bit different. But this one says, if the legs of a right triangle are 4 units and 1 unit, then the area of the square on the hypotenuse is 17 units, because 16 plus 1, the area of the 2 legs, or the squares attached to the 2 legs, is equal to 17. So ultimately, the pattern that you're discovering in problem 3.1 is a special theorem in mathematics. Again, a theorem is a general mathematical statement that's been proven to be true. And this theorem in particular is named after the Greek mathematician Pythagoras. And the Pythagorean theorem states a relationship among the lengths of the sides of a right triangle. Make sure you're noting here that this is a right triangle. This is also one of the most famous theorems in mathematics. And you have a little bit of information here also about Pythagoras. He lived in the 500s approximately BC. He had a very devoted group of followers, and they were called the Pythagoreans. And the Pythagoreans were pretty powerful. Their influence became so strong that some people feared they threatened the local political structure, and they were ultimately forced to disband. However, many Pythagoreans continued to meet in secret and to teach the ideas of Pythagoras. Again, the Pythagoreans held Pythagoras in high regard, so high that they gave him credit for all of their discoveries. Much of what we now attribute to Pythagoras may actually be the work of one or several of his followers, and that includes the Pythagorean theorem. So hopefully when you come to class tomorrow, you're ready to dig more into what is the Pythagorean theorem, why is it important, and how is it going to help you understand some other big ideas in math.